Today we're going to do the notes on Chapter 2, Lesson 2, or Unit 2, Lesson 2, on erosion and deposition by wind, ice, and gravity. We already learned about erosion and deposition through water, so we talked about rivers, we talked about groundwater and the ocean, of course. And today we're going to talk about all of the other forces on Earth that can do this very similar things. They can shape our landforms by building up and breaking down the land. So the first force we're going to talk about is wind. Okay, so wind is pretty powerful. Obviously happens on the surface of the earth, but wind can cause erosion by blowing around the sand and sediment that is on the surface of the ground. So you might see what's called abraded rock. This here is an example of an abraded rock. This happens when we're looking at like a rocky, sandy desert area where the wind picks up sand and blows it around. And basically what that does is that sand blasts the denser rock in the area. So that's why you see this rock here closer to the bottom is more worn away than it is at the top. That's because the sand is heavy enough that it wants to stay closer to the ground. You know, it's heavy enough that the wind can't pick it up all the way. So as the wind blows it around, it's going to wear away the bottom areas of those rocks. Okay, so that's called abraded rock. Desert pavement is another formation that we get from wind. This is from wind blowing away sand and sediment. So if the wind is blowing in a desert area where there's lots of sands, finer particles, as well as bigger pebbles and rocks, if the wind blows, it's going to take away the lighter, less massive particles. So it will leave behind the bigger pebbles and rocks. And that's whatever's left over, that's what we call desert pavement. So desert pavement happens when wind erodes sediment, leaving behind those bigger rocks and pebbles. We also see deposition happening with wind in the form of a sand dune. So a sand dune and actually a loess as well. So those two pictures to the right. Dunes are mounds of wind deposited sand. And they have kind of a cool shape. So they have a gentle slope here coming up the side. This is the direction of the wind. So the wind is going to be blowing. In this example, the wind is blowing from left to right. So this is a gentle slope here. And then the back is a little bit steeper, and that's what we call the slip face. We usually find sand dunes pretty close to where you find the sand. So like at a beach or in like a sandy desert like the Sahara. Loess is kind of similar to a sand dune, but it's usually much finer grain sediment. So because it's much finer, we can find loess farther away from their source. Loess are good for growing crops because it's very, very fertile soil and it's finer grain. So it's easier to plant things in it. Okay, so abraded rock and desert pavement are examples of wind wearing away and taking away those particles. And then sand dunes and loess are examples of deposition. So the wind is blowing that stuff to a new location. This is a video that just shows you the formation of sand dunes in a desert, a sandy desert. It's linked in your notes, so I suggest you watch that. It's pretty short. The next force we're going to talk about is ice. And I know ice is really just frozen water, so we could have talked about this in 2.1 when we talked about water, but it's also obviously a solid, so it behaves just slightly differently. So ice can cause erosion and deposition and weathering as well. It just happens kind of slowly. Usually this happens in the form of glaciers, and there's actually more than one kind of glacier out there. But all glaciers are formed from snow that falls and then gets squished down and compacted. So when that happens, all that snow being compacted turns into a very dense ice. Gravity is going to play a role in the movement of these large sheets of ice. Um, and it's going to cause all that stuff to go downhill. It's going to flow downhill just very, very slowly because it's frozen. As these glaciers flow and as they move and as they retreat from melting or moving or whatever, gravity, as they retreat, they're going to pick up rock and scrape out some rock as they go. So they're going to pick up and move rock as they flow. There's two different kinds of glaciers here. The one here on the left is called an alpine glacier. Alpine glaciers form high up in the mountains, and usually you'll see them flowing in between those mountain peaks. Continental glaciers are those big, huge glaciers that we picture covering like Greenland or like Antarctica. Those are continental glaciers. Those are huge, thick ice sheets that cover like flat land. Both of them can cause erosion by like scraping out land. Both of them can cause deposition by leaving behind rocks and boulders and like trails of sediment and stuff like that. But they're two different kinds. Usually alpine glaciers are a little bit smaller because they're found in the valleys. Continental glaciers are huge ice sheets. And continental glaciers are where we also get the icebergs, where they break off and land in the ocean. The rock and the sediment that's left behind by a glacier, that's what we call glacial drift. So you might see that term around, glacial drift. Drift is, in this case, it's a noun. It's not a movement. It's not an action. It is an object. It's a thing. So glacial drift is just the name that we give to that sediment and that rock that is left behind from glaciers. This is a video about how glaciers can shape the landscape. I'm not going to play it for you here. It's linked in your notes. Definitely watch it because she gives a really good view of how glaciers can shape the landscape. So like I was saying before on the last slide, there's two different kinds of glaciers. We have alpine glaciers and continental glaciers. Those alpine glaciers are the ones that we find in the valleys of mountains. And typically what they do is as they flow very slowly, they scrape out the sides of those mountains. So what was a harder V-shape valley, they get scraped out and they become rounder U-shaped valleys. So these smaller mountain glaciers that carve V-shaped valleys into U-shaped valleys, that is an alpine glacier. And you can see here, these valleys in between these mountain peaks are a little bit more rounded, right? That is evidence that alpine glaciers have flowed through there. Continental glaciers are those big, thick ice sheets that we imagine when we think of Antarctica or the North Pole or Greenland. These are those big ice sheets that cover huge expanses of land. As they retreat and as they move, they flatten and smooth the landscape. As they flatten and smooth the landscape, they kind of act like big ice bulldozers. So they're shoving rocks out of the way, they're picking stuff up and moving them, pushing rocks out of the way. And they form what we call kettle lakes, which are these little bowl-shaped depressions in the land. We have lots of them here in North America. And then they also can sometimes leave behind these huge boulders called erratics. These erratics are massive. They're absolutely massive, and they're really impossible for any other force to effectively move them. So ice is a very, very strong and powerful force. Gravity is the last type of force that we're going to talk about. Gravity can cause erosion, and this is what we call mass movement. Gravity can cause mass movement. Slower mass movement that you might not see happening in front of your eyes, that's what we call creep, and that's exactly what it's doing. The soil is creeping down a hillside. So gravity is pulling that soil very slowly. If there's a lot of moisture in the soil, it's going to want to move a little bit more. And we don't typically see creep happening. We see evidence of creep happening. So this picture here in the top left, this is a picture that shows us that creep has happened. We didn't see these fence posts moving. And when they very first installed those fence posts, they were standing straight up and down like you would want to have a fence. But over time, the soil on this hillside started to creep downward. The soil on the surface, through rainwater and everything, got a little bit more moist than the soil that's deeper underneath. So the soil on the surface started to slide downhill a little bit more, knocking the tops of those fence posts over. And then so we see evidence of that soil movement in the fact that all of these fence posts are now kind of sideways and crooked. So that's creep. Creep happens very, very slowly. You don't see it happening in front of your eyes. Fast mass movements or rapid mass movements are rockfall, landslide, and mudflow. And those are exactly what they sound like. Rockfall is a ton of rocks that have fallen down a hillside. Landslides is where a big chunk of land falls at one time, and mudflow is where, after a lot of rain, you'll see lots of mud overtaking a landscape. This is typically caused by, yes, gravity, but also something else that's triggering the rockfall, landslide, or mudflow. Could be something like deforestation, so us taking down trees. Tree roots are really good at keeping soil in its place. So if we deforest an area and we take out those tree roots, then that makes that soil a lot less stable. Heavy rain can be a big issue, so major storms, construction, shaking up the landscape can be a huge catalyst for rockfall, landslide, and mudflow. And volcanoes. Volcanoes and earthquakes, when they shake up the land and they move things around, that's going to loosen whatever rocks, land, or mud might be in that area. Volcanic eruptions can also melt a lot of snow at one time, which can then turn into lots and lots of mud flow at one time. This is a video from National Geographic of, it's kind of a mud flow, even though it's labeled landslides. I definitely suggest you watch it. It's interesting. All right, so those were the 2.2 very quick notes on how wind, ice, and gravity can cause our landscape to change over time.